Question 5 says factor each quadratic below completely. The first thing I notice with A is that there is a common factor of 2, so I'm going to factor that out. So this becomes 2 times the quantity of. And now what I'm going to do is divide every single one of these 3 terms by a 2 and write what's left over. So 2x squared divided by 2 is x squared. Negative 2x divided by 2 is negative x. And negative 4 divided by 2 is negative 2. So that's getting out the greatest common factor. And then I'm going to go ahead and use what we've been using in class quite a bit lately, right? We're going to use the generic area model and a diamond problem to factor this. Let's see, I know that I have x squared and negative 2. And the product of those, right, x squared times negative 2 is negative 2x squared. And this middle term here, the b term, is negative 1x, right, negative x. So I need factors of negative 2x squared that produce a sum of negative x. And this isn't too difficult, this one. So this is a negative 2x, and then I'll say it's a plus a 1x. So if I multiply those two, I certainly get negative 2x squared. And when I add them, I definitely get a negative x. So I'm going to go ahead and write those two values, and I'll use a different color for it. Right, I'm going to write this value right here. This is the negative 2x. And I'll go ahead and write the x right here. So after I've placed those in, my strategy is usually to look for a greatest common factor along here first. Right? So when I look at x squared and x, the greatest common factor I have for those two is an x. And then I generally look for the greatest common factor this way next. And if I look at it, I've got a negative 2x and an x squared, and my greatest common factor there is just x. So then it's a matter of filling in two values, right? So for example, right here, what do I multiply x by in order to get negative 2x? And the answer is you're going to multiply that by negative 2. So this is a negative 2. And then what do I multiply? Let's see. What do I multiply? Oh, what do I multiply this x by in order to get an x? Well, that's going to have to be the number 1, right? So because 1 times x is x. So if I look at this, right, I can see for every single one of the individual boxes here, let me do this with a pen that'll erase itself. If I multiply x times 1, I get x, right? X times 1 is x. If I multiply, let's see, this x times x, I do get x squared. So I've checked the bottom two. If I multiply this x times negative 2, I do get negative 2x. And also if I multiply 1 times negative 2, I do get negative 2. So this is exactly a factor model that uses the generic area formula, or generic area rectangle. So my factored form of this is, let's not forget I had a common factor of 2, but then my two factors are x minus 2, and the other factor is, oops, I don't want these to erase anymore. Let me get rid of that. So I have a 2, and then I have an x minus 2, and then I'm multiplying that times x plus 1. So I just did it actually with the box above, but when I multiply those three things out, I do indeed get my original trinomial. I'm just going to get you started on B. I think you can finish it off. The one thing that I do notice on B is I have a common factor of 4. So when I bring out that common factor of 4, I'm left with an x squared. Negative 24 divided by 4 is negative 6 times x, and 36 divided by 4 is 9. So I've removed my greatest common factor, and your job right now, right, is to fill out this generic area model and then to use this diamond problem to factor this completely. I've got an x squared and a 9 here. So the product of those two is 9x squared. And I need to play with factors of that so that I can get a sum of negative 6 times x. And I'm going to leave this one for you to complete on your own.